Hello everyone, welcome to the week 8 of the 3 months data analyst roadmap. In today's video we are going to continue the Advanced SQL series that we started in the previous week. Remember, in week 7 we started off with the basics of SQL commands. So in this week we are going to continue the advanced series that we started in the previous week, and we will be doing 2 projects in this week as well. Today we are going to talk about aggregate functions, group by class, having class, subqueries, and some more topics. So let's begin. In SQL we have some aggregate functions that are mostly used for different functionalities. For example, we use sum function for getting the total of a column. Then we have count function for counting records, and then we have for example average function for getting the average of a column. Similarly, we have max function for getting the maximum values, and a minimum function for getting the minimum value. So we will be learning all these functions in today's video. The first one is sum. Let me show you the orders table that we have been working on in the previous few videos. So if I describe the tables and I select star from orders, let me limit the result to 5 rows. So we have an overview. We have ID, customer ID, the order date, and the amount. For example, for some reasons, if I want to get the sum of the amount column, I can use the sum function. So let me clear the screen. I can say that select sum of amount from the orders table. If I run this query, it will return the total of the amount column. So this is 111, 78, and 900. This is the total of the amount column in the orders table. Of course, we can add different conditions to this query, and we can get the results based on our own choice. For example, I can say that select sum of amount column. I can add a where condition where the amount is greater than or amount is less than let's say 2000. Sum the amount column of those records where the amount is less than 2000. So if I press enter, oops, I did not mention the from class. So from orders table and where amount is less than 2000. So it says that there is only one record, I think, that the amount is less than 2000. Let me check this. Let me select star from orders and order by amount column. Let me press enter. Order by, I missed by. So yes, the only amount that is less than 2000 is 1850. So let's modify the query so we can see the results clearly. Select sum of amount column from the orders table where the amount column is less than 2500 this time. And if I press enter, it will sum only those records where the amount column is less than 2500. So we can use sum for getting a total of a numerical column. Similarly, let me open the notepad. We have count. If I say that select count star from customer table, count star means that count all rows. Okay, here the star means that count of all columns together. Star means the same here. It means that count all the values in all the columns. So for example, if there are 5 columns and one column has 2000 values, but the second column has 1000 is missing, then it will count the maximum column values. Because we are mentioning a star here, it means sum all the rows. So all the rows, if there are empty values in one column but non-empty values in another column, it will return all the non-empty values. So select count star from customers. If I add semicolon and press enter, not customers, it's customer. So it says that there are 2000 records in this customer table. Remember that in the previous video we checked the email column where there were null values. Let's check that again. Select count star, select email from customer where email is null. So there are 4 records where the email is null. You can see this, there are 4 rows. So if I say that select count star from the customer table, it will return 2000 that we saw before. But if I say select count email from customer, it means count all the rows based on email column. It means all the values in the email column. So if I add a semicolon and press enter, it says that there are 1996 values. There are not 2000 values because we have 4 missing values. So if you want to count all the rows, you will use count star, and that will return non-empty values even if they are in one column. But if we use count with a specific column, it will count only the values of that specific column. So count is used for counting the rows. Let me clear the screen. Next we have average, max and min. Let me use all of them in one select statement. Select average of amount, comma, max of amount, comma, minimum of amount from the orders table. If I press enter, it will return the average is 5589.45, the maximum value is 9000 and the minimum value is 1850. Now that we understand how to use aggregate functions, let's see the actual use of this. The actual use of aggregate functions comes with the group by class. So we use aggregate functions whenever we want to group the results by a specific conditions or group by a specific column. So let's learn that as well. First of all, let's select all the data from the orders table and limit the result to 5 rows so we can see the columns. We have ID, customer ID, orders date and amount column. In this case, in this table we might have some customer IDs who have placed more than one order, and we want to sum the amount of all the orders that they have placed. For example, I have fetched some IDs and I have written them in this notepad file. These IDs have placed more than one order. Some of them have placed 3 and some of them have placed 4. So before going to the group by, let's first check these IDs and their records in the orders table. So I'm saying that select star from orders where customer ID in these IDs. So we can get the list of these IDs by using the n operator. We have studied n operator in the previous videos. So if I add semicolon and press enter, remember that for each customer ID there are more than one records. So the first one is 1987. It has one record by the ID of 398. Then it's repeated again 1987 with ID 758. 1987 is repeated 3 times, and at the end we have 1987 again. So 1987 customer has placed 4 orders. 682 has placed 2 here and 1 here, 3 and 1 here, 4. So these are the IDs who have placed more than one orders. Now we know that we can use these IDs specifically to check the group by class results. So let me clean the screen. I can say that select customer ID, comma, sum of amount from the orders table where ID in this list. I'm adding this list specifically for seeing the results, because if I don't add this list, we will not be able to see the result, because there are 2000 records in the table. If we scroll down, you will not understand. So for the sake of simplicity of learning, I'm adding this list. Now I'm saying select customer ID, comma, sum of amount from the orders table where ID is in this list. Now I'm saying group by customer ID. Why group by? Because one customer ID has 3 or 4 records. Now I want to show the customer ID and the sum of all the amounts of the 4 records or 3 records that they have placed. So if I add semicolon and press enter, oops, I made a mistake. Instead of customer ID, I just said ID. So I need to correct this customer ID in this group by customer ID. And now if I add semicolon and press enter, you will see the result. So 539 has total 16,350 amount, 764 has 22,850, 682 has 24,950, and so on. So what this query did, that it grouped the amount of 3 or 4 records, summed them, got a total of this and grouped it by the customer ID that we have given it in the condition. If I remove the condition where class and just group by customer ID, we will see the same result, but we will see it for all the records. So we can see that here we cannot understand that which ID is repeated. Therefore, I just got specific customer IDs that I had checked before, that they have placed 3 or 4 records, and therefore we got the sum of the amount for all those IDs. So we use group by class to group the results based on one specific column, or we can get it by more than one specific columns. To illustrate group by class properly, I have added another table by the name of products. Let's see that and then use a group by class there as well. So if I select star from products and see the result, we have ID column, name of the product, the category, and profit. So first of all, we have 2 categories, electronics and clothing. So in the entire table we have only 2 categories, and in each category we have different products. For example, we have laptop and electronics, we have smartphone and electronics. Similarly, we have shirt and clothing, and we have jeans and clothing, but we have different records for each product and each product sale. So here, if I want to see the sum of the profit by each category, what I can do is to run this query. Select sum of profit from the products table where category is equal to electronics. Add semicolon, press enter. It will show me the total of profit for electronics category. If I repeat the same query but change the category name to clothing, it will return the sum of clothing for me. But this is not the right way, because we have only 10 records here and we have only 2 categories. What if we have 10 million records in a table and we have, for example, 100 categories? Then we cannot repeat the same query 100 times. Therefore, we can use the group by class. For example, I can say that select category comma sum of profit from the products table, group by category. So it will group the profit by each category and will return the sum of the profit in front of each category name. So if I press enter, it says that for electronics we have 2810 and for clothing we have 785, that we saw before in the where class. We can also use group by class for each product. Instead of category, we can use it for product. For example, I am saying that select name comma sum of profit from products table, group by name. So it will show the total of profit for each product name here. We can use category and product in one statement as well. For example, we can say select category first, then select name, and then show me sum of profit from the products table, group by. Remember that we have added category and name together, therefore we need to repeat all the columns in the group by class. Whenever we have an aggregate function and some column names, then in group by class we need to repeat the column names, because if we get the sum of one column and we have two columns, then group by class cannot get the sum of one column, because it does not understand how to get the sum of one column and leave the one missing. So we need to repeat both of the column names here. So group by category, comma, name, add semicolon, press enter, and it will show category clothing, shirt we have 455, for clothing and jeans we have 330, for electronics and smartphone we have 1050, and in electronics for laptop we have 1760. So you can group the results by each column that you want. Similarly, we can use the other aggregate functions like average, max, min, and count in the same way. Let me use count this time. Select category, comma, count, star, from products table, group by category. It says that in electronics we have 4 rows and clothing we have 6 rows. So it will count all the rows based on the column that you have grouped by. So this is how we can count the rows by a group. We can use the same group by class in our previous tables as well, like in orders table and customer table. So let me use the group by class on orders table. For example, select customer ID. For example, if I want to know that show me the number of records or the number of orders for each customer ID, I can do that as well. Select customer ID, then count star, from orders table, group by customer ID, add semicolon, press enter, and it says that ID 1489 has 1 order, 1989 has 2 orders, 273 has 1, 1560 has 2, and so on. You can see all the result. Even we have 1899 that has 3 records or 3 orders. So this is how we use group by class with aggregate functions together. What if I want to show only those records from the orders table or those customer IDs from the orders table who have placed more than 1 records? In my previous statement that I ran, it shows the customer ID with number of orders, but the problem is that it also shows those customer IDs who have placed one order. Now I don't want to show them. I want to show only those customer IDs who have placed more than 1 orders. So not 1 but more than 1, 2 or 3 or 4 or more than that. So how can I do that? Can we add this condition in the where class? Let's see. If I repeat the same statement, but after from orders I say where count star is greater than 1, show me those records who have placed more than 1 orders. So I'm saying that select customer ID count star from orders where count star is more than 1. It means where there are more than 1 orders, group by customer ID. Will this work? Let's see. If I enter this, it says that there is a problem. Aggregate functions are not allowed in where class. Remember, aggregate functions are not allowed in where class. We use this count star aggregate function in the where class. So how can we add this condition? For adding such conditions, we have another class that's called having class. So for adding a condition where we use the aggregate functions in the condition, we are not allowed to use it in where class, but we have another class that's called having class, and we can chain that with group by. So let me repeat that statement and let me clear this from here. I'm saying that select customer ID count star from orders table, group by customer ID, having, let me write having in capital letters, having count star greater than 1. Instead of where, we can use having and we can specify our condition where we can also use the aggregate functions. Remember, in having we only use aggregate functions. Now we cannot say that having amount column is greater than 2 or having this column is equal to this. No, we can only use aggregate functions in the having condition. So if I press enter this time, we can see that we only have those records who have placed more than one order. Or we can also change the condition to say that show me only those records who have placed more than 2 orders, and we can see 3 and 4 only. So this is how we use conditions in the group by class. This can be a good example for finding duplicate records. So if you have duplicate records, you can use the same query to get those records which are repeated more than once. Now that we understand group by and having, let's use both of them with joins to get those customer names and their emails who have placed more than one orders, and get the sum of the amount column from the orders table for those customers. So first of all, let's count them. Select c.name or customer.name, comma, c.email, comma, count star or count o.star, order.star from customer table C, inner join orders table O on C dot ID is equal to O dot customer ID, group by C dot name, comma, C dot email, having count O dot star greater than 2. If I press enter, it will show me the name and the email of those customers who have placed more than one order in the orders table. Let's close this and modify this query to get the sum of the amount for these customers. So O dot amount, and instead of count I want to sum this, sum, and at the end I need to change this count as well to sum of O dot amount. Okay, so let's remove this having class because we just want to see the sum of amount for every customer who has placed an order in the orders table, and it will show me the sum of amount for everyone. So Jeffrey Woodward, who has placed more than one records, because we understand from the sum amount is 18,050. We can see this one, that's Matthew Thomas, because the amount is very high. The highest amount for one order that we had in this table was 9,000. So if it's more than 9,000, it means it is repeated. It has more than one records in the orders table. So we can use group by class and having class with joins and where and everything else. The next topic that I want to talk about is the case statement. Somewhere and sometime you might need to add conditions to your queries. For example, if we take the orders table, we can say that every order that is more than 8,500, I want to give it a title as the super order or the best order, and the order that is between 7,000 and 8,000 or 8,500, that is, for example, a good order, or everything else is a fair order. So if I want to give a name to each order, I can do that with the help of the case statements. Case statements are used to add conditions to our statements or SQL statements. So let me show this with the help of an example. I can say that select show me the customer ID, for example, or show me everything. Select star from, I can say that select star, comma, case when the amount column of the order table is more than 8,500 8,500, then call it super order. So if the amount is greater than 8,500, I want to call it super order, comma, not comma. Remember, in case statement, when we add conditions, we do not separate them with a comma. Okay, so give it a space and add another when the amount is between 7,000 and 8,500, then call it good order. For everything else, I need to call it fair order. So else fair order. So here we added 3 conditions. First of all, whenever we want to add a case statement, we need to start it with case. Let me expand this. So we need to start it with case. It will start the condition. Then we need to mention the conditions in when class. When, for example, I said that amount is greater than 8,500, then call it super order. I need to add another when, so there is no need for a comma. If we add a comma, it will give us an error. When amount is between 7,000 and 8,500, then I want to call it, for example, good order. Here, if I want to add more conditions, I can just add it by adding when clauses. So because I do not have any other condition and I want to call it a fair order for every order that are not fit in these 2 conditions, then we can say that else call it fair order. Now I need to end this case statement, so I will say end. Okay, and I can give it a name because this will be a column that has either super order or good order or fair order values, so I need to give it a name. So I will say end as, for example, order type. I'm adding this case statement to my SQL statement here. So I said case, when amount is greater than 8,500, call it super order. When amount is between 7,000 and 8,500, then it should be called good order. Else it should be called fair order. Now I need to end this, end, and call it order type as order type. If I add semicolon and press enter, remember I have not mentioned the from class. Okay, so from the orders table, and here we have the result. So we have ID, customer ID, order date, amount, and the order type that we mentioned in the case statement. So if any order that has the amount of more than 8,500, it will call it super order, and if that is between 7,000 and 8,000, it will call it good order. For every other order that is below 7,000, it will call it fair order. So this is how we use case statements to define conditions in our SQL statements. So the next and the interesting topic is subqueries. Subquery is a query within another query. Yes, we can have one SQL statement within another SQL statement, and the example would be something like that. For example, if I want to get the list of those customers who have placed more than 2 orders in the orders table, I can do that with the help of joins as well, but it will be very simple to use subquery instead of joins. For example, I can get the list of those customer IDs who have placed more than 2 orders from the orders table. So I can say select customer ID, comma count star from orders table, group by customer ID having count star more than 2. So it will return all those IDs. What I can do here is to get the list of these IDs that we have already gotten the list, and we have gotten only 5 IDs. For example, this is the entire list of those IDs who have placed more than 2 orders, just for the sake of example. Now I can provide this list, I can copy this, and I can provide this list to another SQL statement. Like I can say select star from the customer table where customer ID is in this specific list. If I add semicolon, press enter, so these are the customers who have placed more than 2 orders in the orders table. What I did here, that I added the list manually. I copied the list from the orders table and I added the list manually to this in operator. What I can do is to, instead of providing the manual list, write the query to get these IDs from the orders table. Can you get the point? For example, I can say that select, let me bring back that statement, yes, this one, select star from customer where ID is in this list. Instead of providing this manual list, I can write a select statement, select customer ID from the orders table group by customer ID having count star greater than 2. If I run this query, it will return the result like this. It will give me all the customers who have placed more than 2 orders in the orders table. So what I just did was to provide a query that can get the list of those IDs from the orders table. It will first get the list from the orders table, then it will provide the IDs of that list to this in operator, and after that the outer select statement will run and will give us the customer list. So first of all, the query which is inside the parentheses, it will run, it will get the customer IDs from the orders table, and then it will provide the IDs list to the outer query. Outer query will execute based on the given condition. So we can use subqueries for dividing a complex problems into small chunks. So let's work on another example. For example, if I want to show only those customers whose sum of amount of all orders is greater than 30,000. For example, they have placed 2 or 3 or 4 orders, but the sum of their amount of the orders make more than 30,000. So I want to show only those customers. What I can do is to write the same thing. For example, select star from customer table where ID is in this list. Again, I need to provide the list of those customer IDs from orders table whose sum of amount column is greater than 30,000. So I can say that select customer ID from the orders table group by customer ID having sum of amount column greater than 30,000. So what happens here, the inner query will get those customer IDs from the orders table who has the sum of amount more than 30,000. So they have placed more than 1 order and the sum of their orders amount will make more than 30,000. So let's see and press enter. Yes, there are only 3 customers who have placed orders where their amount is more than 30,000. So this is how we use subqueries to divide our complex problems into smaller chunks. In this video, we worked on the aggregate functions, the group by class, having class, case statements to add conditions into our queries, and at the end we worked on the subqueries. So from the next videos, we will be working on 2 data analyst portfolio projects, and we will be working on SQL projects there. I will also give you a data set so you can also work on an SQL project and add that project to your portfolio. That's it for today. Thanks for watching.